Hi, welcome to this tutorial. This is Teacher Raya. In this session, we're going to solve question 2 from my predicted paper for Form 4 Math 2020. So if you haven't seen it, please look for it on my playlist of predicted paper 1. I must say this is mostly for Form 4 NECTA students, but it is helpful if you're doing any Form 4 exams in East Africa, I would say. Okay, so let's start with question 2a. Then there is part B to it, so please hang on. We're told to use mathematical tables to find the reciprocal of 0.0247. Hence, evaluate all these correct to 2 decimal places. So what does reciprocal mean? It just means 1 over. So if I say reciprocal of x is going to be 1 over x. If I say reciprocal of 2 over 3, it's just going to be upside down. Sorry, that is reciprocal of this one. That's going to be equal to that. So basically what we want to do is just 1 over this number. So let's just do that. 1 over 0.0247, which can be written as 1 over 2.47 times 10 to the power negative 2. Okay, so this can now be written, well, if you are familiar with it, because this is a negative, it can go up as numerator as positive. But if you don't know why, then I can just quickly show you. So let's say, for example, we have 1. 1 times 1 is just 1. So we can say 1 times 10 to the power 0, because 10 to the power 0 is just 1. Anything to the power 0 is 1. And then we still have 2.47 times 10 to the power negative 2. What do we do with indices when we divide? We subtract the powers. So I've got here powers of tens. For the numerator, 10 to the power 0, 10 to the power negative 2. I can subtract the powers. So I can go ahead and do 1 times 0, take away negative 2. So that becomes positive. So now I have 1 times 10 to the power of 2, and I still have my 2.47 here. So now I can go ahead and do 1 over 2.47 times 10 to the power 2. If you go ahead and look at your tables for the reciprocal of 2.47, this will give you 0.4049, and then we multiply by 10 to the power 2, you know it's just 100. So the final answer is 40.49. So that is this part here completed. And now for the second part, we are asked to evaluate all this. Correct to 2 decimal places. So I'm going to say let x be equal to all that number, so square cube root of 3.025 over 0.0247. We already know 1 over this is 40.49 from the previous question, so I can write that as 40.49 times the cube root of this one. So I'll just go ahead and write it first, 3.025. Now we know we can write that as 40.49 times 3.025. It's a cube root, so we can have as a fractional power. So 1 over 3. Anything to the power of 1 over 3, it means the cube root of that number. So we still have our x here. Now what I'm going to do is take log on both sides. So I'm going to say log x is equal to log of all this, 40.49 times 3.025 to the power of 1/3. Okay, we can use the product law to separate these. So we can write log 40.49 plus log of 3.025 to the power of 13. So we can go further and say this 40.49 is actually 10 times 4.049. So I'm going to separate this, because 40.49, if you just write that as 4.049 times 10, so I can separate that. I can write that as log 10. I use the product law again, so plus log of 4.049 plus, what do I do with the power? So again, I need to bring the power over here. So that means it's 1/3 of log 3.025. So I'll carry on over here. So what do I have? I have a log x is equal to log 10. We know that's 1. And then we can plus a log of 4.049. That's going to be 0.6073 plus 1/3 of a log of 3.025, which is 0.4807. Okay, so now I'm left to do is just try to add all these up. If you add them up, you will get 1.7675. So this is my log x. Now I can take the antilog in order to find x. So x is going to be equal to the 10 to the power of 1.7675, which can be written as 10 to the power 1 times index law. Okay, so times 10 to the power of 0.7675. So this is equal to 10 times. So if you find the antilog of 0.7675, it will give you 5.855. So the final answer is going to be x equals to 10 times that, which is 58.55. And that is already in 2 decimal places. So that is our answer for this part. Right, for part B, we've got equations. Then we need to solve and find what x is. And I'm just going to go ahead and simplify this very quickly. We can write log 32 to the base 2 as log 2 and then 2 to the power 5 plus again log to the base 2 and then 2 to the power 4, everything over log x base 2 equal to log x base 2. Okay, so we can bring the 5 here, and then I have 5 log 2 to the base 2, which is going to be 5 times 1. So for this part, will just give me 5. Similarly, I can bring the 4 over here, and then log 2 to the base 2, that will be 1. So that then I have 4 times 1, which is just 4. And then I have my log x base 2, which is equal to that. What I can do now, add those, so I have 9. Now I can multiply both sides by log x to the base 2 in order to get rid of this, which means I'm going to have something like this, a log x base 2 times log x base 2. Now don't make mistake by saying this is equal to log x plus x. No, it doesn't work like that. This is equal to log x to base 2 squared. That's what it means. So now to find just the log x base 2, we need to square root both sides. So square root of 9, I'm going to do like this. Okay. So sorry for my symbol there. So now I have a 3 is equal to log x to the base 2, which means if I want to find what x is, I can now write it as 2 to the power 3 is equal to x. Therefore, x is equal to 8. All right, so that is the solution for question 2. Thank you for watching. Bye for now.